single thing.
Yeah, so you did.
Did anyone sit at my table?
Yes.
Bruh. No.
What if you?
This may not
Why would you do that?
No.
Hannah,
Yeah.
what did you do?
Why not?
Here, give me some of that.
Yeah, stick ready.
Yeah.
Whoa.
This would be
Are
a
you sharing with everybody, Tanner?
Well, it kind of fell off and it started rolling.
All right, that's fine. Yeah, just take a piece and go. I mean, Jay. Hi. How are you? It is so
Something
good
for
to
the rest
see you.
of the year?
I got this
Did
one.
you go get something? Did you get something warm up? Okay. Hey guys, I'm gonna report our class today, okay? So I can post it to YouTube. Just FYI. I'm recording our class today so I can post it to YouTube. Usually I record West days, but
Yeah, I
wanna
look
get it
good
done,
today.
okay?
Wait, you record West for people that are at home?
No, I record my West Day classes so that you guys can have reference when we talk about it if you're on quarantine. Okay?
Is it live?
So don't do anything
Not
embarrassing.
now, but during SLT,
Wait, so is it?
maybe.
Because let's go on
Is it
YouTube.
acting weird?
Just
Where everyone can see.
No,
Go ahead and say it.
You're trying to 50 something.
Okay, yep, well, why don't you start with that?
Probably not that many. Is it just her? Maybe.
They don't hear your voices, and I'll see you video with this guy.
So random. People are gonna look.
Okay, but it'll pick up our conversation. It's picking up our conversation.
Yeah, he's gonna walk up. He's gonna walk.
So,
It's on mute, so you're a liar.
no, my computer's on mute, my iPad is recording,
Oh.
okay? My computer's on mute so they don't conflict with each other. Okay.
So I'm a liar.
Yeah, and all this is going up to YouTube tonight, so
Oh.
So I'm gonna be YouTube.
go ahead and fire up everybody.
No.
My voice. So is everything we just said gonna be
Well, I'm not gonna edit it out probably.
okay? Oh, good.
So it's a good thing, everything in there is a green light, right? I mean, it's okay for us to have a conversation before we get started. It's just for our class, I mean, it's not like it's just for Noah's, we're gonna try to broadcast it for the whole world for us to know about, right? Just trying to,
Why doesn't the whole world want to know about that?
well, they might pick up on this and realize that it's one of the best things that ever happened to them, I don't know, okay? I'm just saying that my target audience is right here and the rest of my team, okay? So, I'm not like gonna lose a lot of sleep over if we're having an informal conversation when we get started. Okay? Get started. So that we can have a formal conversation. All right, good to see everybody. Everybody have a good weekend?
Not really.
Okay, I have your assessments for those of you that took it on Friday. For those of you that didn't take it on Friday, and you can take it on Tuesday, which is
Next
today. Oh, you wish.
Yeah, I do wish.
Not too bad. Okay, it's- Today is Tuesday. Retake options available. They'll have another one in about a couple weeks or so, probably at the end of next week or early the following week, and that one will be 28 points. It's gonna be a little bit more than this one too. So I'm not trying to sway you one way or the other. I'm just giving you all the information so you can inform a decision about if you want to take it. Okay. Jay, since you have been here for a while, I'm gonna let you kind of get everything kind of figured out, and you need to talk with me probably on Thursday. Figure out when we're gonna take this. Okay. It's theoretically, you could take one. I figure you try to take one this week, right? There I am at the negotiating table. which I usually don't do. I don't negotiate with children. If you don't go today, it has to be Thursday. Okay? If you don't go today, it has to be Thursday, Ellen. You have to choose, okay? Yeah, Nicole, you too. If you don't test today, you have to test on Thursday. So you have to let them know. That has to be done by then. Okay? All right. Now we haven't had an equation with the slope that's a decimal before, but if you convert that to a fraction, you're in good shape, right? Anybody try converting that to a fraction? 6/10, which reduces to what? Right. 6/10. No, you had half of it. 3/1. There you go. You said 3/10.
Yeah.
Okay. No, 3/5. All right, so I'm going to pull up my graph. We're going to get this going here. All right, so we know that 0.6 equals 6/10, which equals 3/5, right? Are we good with that? So I'm going to change the equation. I'm just going to look at y equals 3/5 x minus 4. Now I can identify my slope, and now I can identify my y-intercept. Okay? Aiden, what's the slope? That's exactly right. 3/5. Very good. Okay, Tanner, what's the y-intercept? 0 what? Look again. That's it. Makes all the difference. Okay? Makes all the difference. Now, your first order pair goes on the y-axis. Okay? I had some students across the team the last couple of days put that point on the x-axis, and they were doomed before they even got started. Okay? So make sure you put that starting point on the y-axis. Okay? Up and down. Okay? Everybody good with that? So 1, 2, 3, 1, 2, 3, 4. It goes right here. Everybody good? Now use your slope. Your slope is 3/5. That's going to go up 3 and right 5. Okay, so up 3 levels, 1, 2, 3. Over 5 levels, 2, 3, 4, 5. The order pair is there. Did everybody see how I did that? 99% of the graphs I'm going to have you graph in this class this year are diagonal. Okay, so if you are getting a horizontal or a vertical line after you do an equation like this, chances are there's something wrong somewhere. Okay, because I will most likely have you graph a diagonal line for right now at least. Okay, does everybody understand that? So make sure you have a rise and a run when you graph it. Okay, everybody? Good. All right, so there's your line. Any questions, guys? All right, I'm going to erase this, get it for tomorrow. You guys get out your notes, okay? And we're going to look at a couple of word problems today. Everybody's favorite, right? Aren't you guys, Jade, aren't you glad today is the day you came back? We can start with story problems. Isn't that fun? All right, so I'm going to get this set up here. Okay, this was our problem from when we finished up last week before the assessment. Okay, that was the one we finished up on Wednesday. Does it look familiar? Okay, good. So now we're going to take this problem and we're going to do some modifications to it. Okay, So I'm going to transfer the things that we used last week here, and we're going to need next on the next couple of problems to compare. All right. So here we go. Here's the new problem right here. All right. So I'm going to put over here what we had on here previously. Okay. It was 500 feet per month. Correct? The equation was y equals negative 500x plus 3,500. Now, this is saying that the drill was redesigned so the productivity was adjusted so the drill can now drill 700 feet in a month. Okay? And my question to you guys is, how does that change your equation for this situation? So what I want you guys to do is write a new equation with this change implemented. So I want you to write a new equation in slope-intercept form with the information given to you. Okay? You're still drilling 3,500 feet. Okay? But the rate at which you can drill is now 700 feet per month. So how does that change the equation? Write a new equation. And after you write your new equation, you're going to share it with your group mates. I'm going to get one answer per group. Okay? So be ready to go. You're going to have a new equation. Okay. Yellow's talk, green's talk, blue's talk. 30 seconds. Go. Good. That's a very quiet conversation. All right. Yellow group.
We have our answer.
Thank you, Owen. I can hear it all the way over here. Okay. What's your answer, Owen?
I don't know.
You don't know what the new equation is going to be?
No. That's our answer.
That's your answer?
Yeah, I don't know.
Okay. Well, hold on to that thought for just a minute. We'll see if we can maybe get some other thoughts come into play here a little bit. Okay. Green group, you guys have an equation to provide me? No. Blue group, are you going to save me?
Yeah.
Oh, they are? Wonderful. What's your, Natalie? What is your equation? Oops, hold on a second. I got to write this thing up here correctly. So y equals negative 700x plus what? I just started writing away and then you hear that you paused. How about that? Okay. Now,
Can we just finish?
you just finished.
Yeah.
That's a coincidence. I bet the green group just finished too. How about that?
Yeah, they probably did.
Did they?
I had half of it.
You're still drilling the same distance. You're just drilling that at a different rate. So the slope's the only thing that changes. Okay. This is the correct equation. Nice job up there. Okay, the group and everybody else. Everybody okay with that? Okay, get it in your notes, all right? We're going to put it in our notes right here. So I already have this filled out somewhat. We're going to put it in here. I'm going to change this to a blue y or a red y equals. We're going to use red for this change. Okay. And underneath there, I'm going to write the original equation because we're going to graph both of them on this plane that I'm about to show you. Okay, which is right here. In fact, I'm going to turn this so it's a little bit easier to get everything in there, I think. Yeah. Okay. Now, before I graph anything, I'm going to make an adjustment here real fast. I'm going to make this a little bit more accurate. Get some new hash marks down here because it was not coming out to be a nice graph before. When you do your assessment, and I give you a graph for this topic, you will get all the information that you currently see on my graph up here on the screen. You will get where 0 is. You will get the titles of the axis. You will also get a starting value and an ending value for each axis, for each scale. Okay? The idea is not to be consumed with trying to figure out what the scale is. So hopefully that's enough information to get you going. And you just have to finish the scale. Okay? So for example, I know going across the bottom here on the x-axis, these are all by 1. Does that make sense? What's the scale going up the y-axis going to be? Raise your hand, help me out here with that. What's the scale on the y-axis? Okay, Owen? Yep. Okay, so the first value here is really going to probably tell you what the scale is. Okay, and then it's just going to tell you the ending value at the very end. So this is 1,000 here on the lux level, 1,500, 2,000, 2,500, and 3,000. So far, so good? Now, if you want to get a picture of this, get a picture of it. And if you've made your own while I've been talking, that's perfectly fine as well. Okay, are we ready to go? All right, so here's the thing. I'm gonna graph the blue equation first. Okay, we'll do that one together, and then I'll let you kind of help me with the road because that one's gonna take a little bit of a trick to graph. Okay, you have to be a little more careful with that one. So let's get our information here. What's my slope of the blue equation? Who can help me out with that? What's the slope of the blue one? Raise your hand, help me out. Bailey? Negative 500 over 1. And what's the y-intercept? Bailey, go ahead and do it again. Very good. 3,500. Okay. Excellent. All right. I need a volunteer for the red equation. Let's go ahead and get this information mapped out here. Okay. Chloe, what's the slope? Very good. And notice I'm writing both of these over 1. Okay. Because you have to have a rise and a run. Does that make sense? Okay. Because if I don't, what happened, I saw on the assessment from some people on the team, was that they forgot when they had an integer for their slope. They forgot to write it over 1, and I got vertical lines. They went up or down, but they didn't go anywhere left or right. And that caused them to probably get confused. Okay? So make sure you have a rise and a run every single time. Okay? And Chloe, what's the y-intercept? Perfect. That's perfectly fine. All right, we're going to start the blue graph. We're going to start at 0, 3,500 right here. So far, so good? Now, sometimes you have to adapt your slope to your graph's scales, okay? So on this one, we have to be careful here. Theoretically, we're supposed to go down 500 and right 1, correct? Okay, but notice your scale of your graph. The scale of the graph, each level represents how much feet on your y-axis. Each level represents how many feet, everybody? 500. So instead of going down 500, in reality, I'm going to go down how many levels? Show me on your fingers. Instead of going down 500 levels, I'm going to go down how many levels? Show me on your fingers. Each level represents 500. 1 is the correct answer. By going down 1 level, I am going down 500 feet. Okay? So that's all I have to do here. So I'm going to go down 500 feet or 1 level, and I'm going to go right 1 level and put my point right there. Everybody see how I got that next point? Good. Repeat, repeat, repeat. Okay? Just keep going. Down and right. Down one, right one, again. Down one, right one, again. I always like to get more points on here for accuracy. As long as you have 2 points, you can stop. Okay? But I like to get more accurate. And then connect them together, you have your graph. Okay? Show me a thumb if you're okay with that one. Everybody good? All right, very good. Now, let's talk about the red equation. Okay? All right, Aiden, where does the red equation start at?
Wait, sorry.
Where's the y-intercept? Can you see it, or need me to zoom in on it a little bit?
3,000.
That's correct. Good job. I'm glad you took a little bit of time to look at it again. We start here at the same place. Okay? Only this time, instead of going down 500 each time, I have to go down how much each time, class? 700. That's going to be a little bit trickier on a 500 per level scale, right? We're going to have to estimate it a little bit. All right? I'm going to show you how to estimate it here now. Zoom in here just a little. We start at 3,500, right? We're going to go down 700. Let's make the number simpler. Let's do 35 and 7. How's that? What's 35 minus 7? Raise your hand if you have the answer for me. What's 35 minus 7, Tanner? 28. So we're going to estimate where 2,800 is. Okay? 2,800 is about halfway between 25 and 30. So we're going to go just a little bit above halfway. Just a tad above halfway. Right about there. Okay? Now, what is 28 minus 7? Aiden? 21. A little above 2,000. Right here. Everybody see how this is working out? What's 21 minus 7? Class. (21 minus 7). Aiden? 14. Yep. So a little bit under 1,500 right here for the next point. Okay. Oh, and 14 minus 7. Okay, so about halfway between 500 and 1,000. A little less than halfway. And then everybody. What's 7 minus 7? Oh, so I hit the x-axis right here then. Everybody good? That should form a straight line, or pretty close to it anyway. Might not be exact. It should be pretty close. That worked out pretty good. Okay, in your groups, I want you to discuss how does the blue graphs line compare to the red graphs line. Okay? So take 30 seconds and discuss those things, and we'll talk on the other side. On your mark, get set, go. How does the blue graph compare to the red graph? Okay, go. All right, are we ready to proceed? Okay, I'm rolling the dice.
Yay. Yes. Me.
I don't want to get these
Oh,
numbers
whoever
right.
sent in this back chairs.
You replaced the day. Didn't you replace the?
Maybe that good light came up here to you.
No.
Or maybe it went over to Aiden. See. Cool. Aiden, how does the blue graph compare to the red graph?
They both start at 3,500.
Okay, they both start at 3,500. Very good. Well, they do, but they end at the same point at 0, in the same place in the x-axis. They go. 1 ends at x equals 5, right? So it took 5 months for the red graph to drill, and 7 months for the blue graph to drill. Okay?
They both go down at a constant.
They do both go down in constant, but is the constant rate the same? No, it is not. Okay, so what we say then is one of these slopes is steeper than the other one. Okay? When we're trying to determine steepness, we look at just the value. We disregard the negative sign. Okay? Because the larger the value, the more steep the slope. Okay? So does the red graph have a steeper slope, or does the blue graph have a steeper slope? Red graph, thumbs up. Blue graph, thumbs down. Which slope is steeper? Excellent. It is the red one. Good. Okay? So, when we compare these, I can say more steep, the same as, or less steep. So if I give you a fill in the blank here with your thumb, more steep, less steep, the same as. Okay? Put your thumb to the side. So, the slope of the red graph, more steep, less steep, or the same as the blue graph? Show me a thumb. The slope of the red graph. Very good. Nice job. It is more steep. Good. Okay? Now, follow-up question. The y-intercept of the red graph. Okay? Higher, lower, or the same as? Okay? Thumb up for higher, thumb down for lower, thumb to the side for the same as. Very good, the same as. Excellent, good. We're going to do the same thing with the next situation, okay? But that way you know how to figure out what slope is steeper, okay? The faster it falls, or the faster it climbs up, if it's a positive slope, the steeper it is, okay? The negative sign just tells us it's going in the negative direction. That's all it tells us. It doesn't affect steepness, okay? The steeper slope has the larger slope value. Are we good? Perfect. All right. And I summarized that right here in our notes. Right here, if you want to get that in your notes, that's fine. If you don't, that's fine too. We just talked about it. And we're going to move on to our final problem of the day, okay? All right. So, new problem, okay? Whoops, it went back on me. There we go. All right. Now, write an equation for part A. Read the problem and write an equation for part A, okay? Groups, discuss your equation, and I'm going to get a group answer from each group in a minute. blew off the hook this time because I saved our money last time. So now it's time for somebody else to go through this, okay? Let's start with the green group this time, so they have an equation for me. Y equals negative 500x plus 5,000. Okay? The other group, what's your equation? You have the same thing. Blue group, what's your equation? You have the same thing? Excellent. Nice job, everybody. Okay? So you have more to dig, right? You have more to drill. More to drill. I've been confusing dig and drill all day, so I apologize for that. So this way, like it was 3,500 feet before, now it's 5,000 feet. It just means we have a different y-intercept this time, right? Okay. Let's see what that means according to the graph then. We're going to go ahead and graph both of these equations on the same plane and analyze them. So let's get to it. All right, I'm going to put our new equation right here. We're going to use green for this one. And you're going to be able to use colored pencils on your assessment so you can differentiate the lines. And if you want to do that same thing on your assignment, you can as well. Okay, you can use them. You don't have to use red, blue, and green. If you don't want to, you can use any colors you want. I don't care. Okay. So y equals negative 500x plus 5,000. And the original again was y equals negative 500x plus 3,500. All right. There's our graph. So we'll go ahead and get that ready to go here. Mark out our scales here. 2, 3, 4, 5, 6, 7, 8, 9. Now mine's not drawn very well, and that's my fault. I'm gonna do something a little bit different here to get my points, so I have an accurate graph. Okay. But rest assured, on your assessment and your assignment, your graphs are accurately drawn. Okay, so your planes and stuff are drawn, so you don't have to worry about that. Okay. All right, so again, the first graph, go ahead and graph the blue line, okay, how it goes. Now, if I remember correctly, it starts here at 3,500, and it took 7 days, right, to drill the entire line. So I'm just going to plot those 2 points and get my graph real fast, okay? What's the y-intercept of the green graph? Anybody know? Riley, you know what it is? The y-intercept of the green graph. Very good. So this one starts at 5,000, right? So what I'm going to do, I'm going to stand up here, and we're going to role play this thing again, and we're going to figure out how many days it takes, or how many months, I should say, it takes to finish the job, okay? So each time I take a step, 1 month passes, and that means 500 feet have been drilled, okay? So starting here, 1 step forward, I've drilled 500 feet. How many remain after a month? Start with 5,000. $4,500. You start at 5,000. You draw 500 a month. So after 1 month, 4,500 remain. Okay. Now after 2 months, how many remain? There you go. After 3 months, do it again. Repeat. It's 5. 6 months. 7 months. 8 months. 9 months. 10 months. Bingo. Okay? So I'm going to have my other point go right there. Connect it, you got another one, okay? So it's done in 10 months. Okay. Now, again, in your groups, compare your blue line and your green line. What's going on here, okay? You give me an analysis. 45 seconds, go. I'm rolling the dice. You guys ready? Yeah, compare them. Okay? What's going on here? All right, Nicole? Hey, it was inevitable. I about picked on everybody else. So how did you do it? Okay? And Jay hasn't made here, so I'm going to take her chicks and try to keep it in the picture. So, what did you guys talk about? Okay. So it took longer to drill 5,000 feet than did 3,500, right? How many months longer did it take? 3 months longer. Does that make sense? It's 1,300 feet longer. Should it take 3 months longer to drill? According to our rate, sure should. Okay, that's right. Okay, let's do the thumb thing again. All right, the slope of the green line is more steep, less steep, the same as the blue line. The slope of the green line, more steep, less steep, the same as. Okay, slope of the green compared to slope of the blue. Slope. Okay, slope. Slope is the same. They're both negative 500. Okay. Now, the y-intercept of the green line, higher, lower, the same as. So the y-intercept of the green line, higher, lower, or the same as the blue line. Higher is correct. Nice job. In fact, these lines, will they ever intersect? No, they will not. Which makes them what kind of lines? They are parallel. You know how you can tell they're parallel? Because they have the same slope. The rate of change is the same. So they're never going to intersect. That's how you get parallel lines. Okay? All right, we're done. Nice job, everybody. Okay? Unless you want to start the next problem. All right.